Finally, we have our word problem. A discount shoe store is having a sale as described in the advertisement shown. So Dan's Discount Shoes is having a sale where you can save 10 to 60% on all footwear, and regular prices are $20 to $80. We want to use the information in the ad to write and graph a system of inequalities that represents the regular and possible sale prices. So let's think of this for a second. If we are saving 10 to 60%, we want to know how much we're actually paying. So if we're saving 10%, we would pay 90%. And if we are saving 60%, we would be paying 40%. That's going to be important because it doesn't ask us to graph how much the discount is. It asks us to graph the actual price, the regular and sale price. Since I know that my regular prices range from $20 to $80, I've gone ahead and set up my graph so that I can get everything from $0 to $80 in, and then my sale prices along the y-axis, I'll use the same scale there. X-axis is our regular price, and our y-axis is our sale price. So we know that the smallest price that we would pay for a regular price is $20. That's told to us right here in the ad. So I can write my first equation and say that my regular price, X, is either greater than or equal to 20. I'm going to have a line that is a solid line at 20. Vertical solid line, and this is equation number 1. Equation number 2, and I'll use blue for this one. I know that my biggest price is $80, and so my prices are going to be between 20 and 80. So I've got to be less than or equal to $80. That's my maximum, so that's going to be another solid line, and it's going to happen at $80, regular price. That's equation 2, or inequality 2, sorry. Now let's talk sale prices. We know that at the most, we're going to pay 90% of our original price. So we can write an equation that says that Y, our sale price, is no more than, which means less than or equal to, 90% of our original price. Well, 90% is 0.9, and our regular original price is X. It's going to be kind of hard to plot a slope of 0.9, but I know that 0.9 is the same thing as 90 over 100. 90% is 90 over 100, and so that's going to be a little bit easier to plot. I don't have a y-intercept in this equation, so I can say that my y-intercept is at 0. And if I want to go 90 over 100, I'm going to go up to 90 and over to 100. So that's way up over here. And I can draw a line between those 2 points. Remember, 2 points creates a line. And so that is number 3. All right, finally, we can do equation number 4, or inequality number 4, and that's going to be the relationship with the smallest that we're going to pay. At the least, we're going to pay 40%. So Y has to be at least 40%, but it might be greater, 0.4x. And again, to make it easier to plot, I can note that that's the same as 40 over 100. So again, I'm going to start at a y-intercept of 0, and I'm going to go up 40 and over 100. So I'm going to get a point here, and I can plot another solid line. Now the one thing that I haven't done yet is shade. So let's go ahead and go back and shade these. And do the hatching first, really, before we shade. So I know that X is greater than or equal to 20. That's going to be shading or hatching to the right because those are the bigger numbers. I know that it's less than or equal to 80. So that's going to go to the left where the smaller numbers are. So notice that I've already boxed myself in between $20 and $80. Now I need to use my last two inequalities to box myself in even more. Y was less than or equal to 0.9x, so less than makes our y values lower. I need shading here below this line. And then finally, I need to shade above the purple line because that's a greater than. All right, the place where all of these overlap starts at 20, ends at 80, and it's between these two sloped lines. I can label this region right here as my solution area. All right, so part B says how much can regularly priced shoes cost on sale? So that's just really asking us to pick one sample point. If we pick a random regularly priced shoe, and then what could the sale price be? So let's just pick some point that's in the shaded region. I'm going to go ahead and pick a point that's at a regular price of 60 and a sale price of 40. So this is just a sample solution. You could have picked any point that's in that shaded region, just to be clear, but a sample solution would be 60, 40. And what does that mean? It means that a $60 pair of shoes could be $40 when it's on sale. Again, that's just a sample. You could have picked any of the points. All right. Finally, we're asked to interpret the solution 40, 20. So 40, 20, let's plot that right here. So that means that the regular price is $40 and the sale price is 20. So let's just say that. Regular price is $40, the X value, and the sale price is $20. So that one's half off. Once we wrote all of our inequalities, we actually could have used Desmos to plot. I chose not to because it was pretty easy just to use the inequalities and plot it from there, but here we go. X is greater than or equal to 20, looks like that with the pink region. You can see that once we bring in the blue, X less than or equal to 80, we have closed off our graph vertically between 20 and 80. Once we bring in the sale prices, we have the green region and then finally the purple region. And so you can see that that matches what we did. Again, you could have used this to graph your points instead of finding the slopes and the intercepts.